colleagues to listen to it afterwards. My name is Joachim Schleich. I'm a professor of energy economics at Grenoble Ecole de Management, and also a researcher at the Fraunhofer Institute for Systems and Innovation Research in Karlsruhe, Germany. And I've worked also a long time on energy efficiency issues, so I'm particularly interested in the outcomes and the presentations of given by the following three speakers. There will be a slight change in the order. The first presentation will be given by Gustavo Marrero. I probably butchered the pronunciation of your name, apologies, on the energy efficiency and energy governance. And Gustavo is a professor of economics in beautiful Tenerife, I think, right? It's La Laguna on the Canary Islands. And I suppose this is where you will give your presentation from. So the floor is yours, about 20 minutes. And then we have a few minutes for questions and answers. And then we will proceed with the next speaker, which will be, I think, Michel Dominique, right? On energy efficiency in the Swiss pulp and paper industry, and we will convene this session with a presentation on the eco support system in the UK, which will be given by Antonius Katris. Okay, Gustavo, the floor is yours.
Thank you very much, Joachim, for the presentation. And first of all, apologies for this change, but family issues and kids issues especially are shocks that we cannot avoid. And secondly, also just another apology because of the change in the title. I mean, this paper, we submit this paper for the conference in 2019. And so, I mean, the paper, as you will know, they are alive. So they change, they improve. So I'm going to focus more on the new part of this research. That is more on this relationship between income and energy, okay? And of course, focusing all the time in this the role that energy efficiency governance has in this linking these two very relevant variables that are the degree of development in an economy and the energy consumption. The understanding this relationship is obviously it is very important for any policy design in energy policy, okay? For instance, if energy consumption growth is positively associated with GDP growth, hence energy policy should focus more on improving energy efficiency more than cutting energy consumption, right? Because that could damage growth. Also, if the degree of development, as an economy growth, implies more energy consumption, that could be harmful for the environment because the generation of energy is polluting. If we go to the literature, there are a huge amount of papers trying to analyze this causality, okay, this double causality. Most of these papers focus on this Granger causality test. Okay, they focus more on time series analysis. And we have this conservation hypothesis that say that GDP is the one that is causing energy consumption, but there is another way around of the causality. There is the growth hypothesis, that is that energy consumption is the one that is causing GDP growth. But when we look at the literature and find all these papers or empirical analysis that focus not only in the time dimension, but also cross-section dimension, like using panel data, we have that the feedback hypothesis is the one that is the dominant one, okay? That is the double causality is the one that the predominant hypothesis. Also, if we go to the theoretical models, in macro models, energy macro models, okay, we have that the double causality should be our starting point, okay? Because energy, on one hand, energy is an input in the production function, in an aggregate production function, for example, as an intermediate input, but also income affects the demand of energy, okay? So, however, if we look at all these papers, what we found is that none of them use an external instrument to control for this double causality, okay? We know that if this double causality exists, estimating one causality to the other in both sides of the causality can generate bias estimation if you don't control for that. Okay, so an ideal approach in panel data, in macroeconomic panel data, is to use these instrumental variables, but for that we need an external instrument variable. Okay, and the question is, are we able to find this instrument in the literature from energy to from GDP to energy? So an instrument for GDP to control this side of the causality or the other way around? And the answer is no. And this was our challenge in this second part of the research. Okay, so which is our strategy? Our strategy was first to find and construct this external instrument for the causality from energy to energy growth to GDP growth. Okay, just recall, okay, for those people that are not familiar in this literature, that an external instrument must satisfy at least two conditions. The first one is that it must be correlated and not weakly correlated, okay, with the variable to be instrumented. In this case, is energy consumption. So we need to find an instrument for energy consumption growth. And the second condition, that is what is called the exclusion restriction, is that the effect over the variable to be explained, that in this case is the income or the GDP growth, can only be generated through the instrument, through energy, okay? So the link should be like this, okay? So the instrument may affect GDP because the instrument affect energy, okay? So this is the channel. This is to be a good instrument. And the second step is that we follow Bruckner. I will explain a little bit in several minutes. Bruckner approach to, once we have obtained this instrument for energy, to analyze the other side of the causality, okay? And in both cases, we're going to estimate by 2 least square. And how do we find this external instrument? So we start reading on this, we have been several years looking at and analyzing all these papers related to governance and institutional quality and how they affect not only economics, but also energy consumption and energy efficiency. And there are several papers, okay, that analyze how general governance, for example, the index of the World Bank, the World Governance Index, how this affect energy efficiency, okay? But it is clear that the World General Index is not expected to be a good external instrument for energy, okay? Why? Because it is not expected that the only impact that the World General Index has over income goes only through energy consumption, okay? This is not a realistic assumption. However, we have this report by the International Energy Agency that they point out the existence of really huge and important differences between general governance and general governance of the economy and energy governance, okay? And so here is our hypothesis that, okay, maybe we can find an energy governance index that could be a convenient instrument for energy growth, okay? Instead of using the general governance, using the energy governance index. And this is what we need. We need an energy governance index. That is our first part of the research, the one that we started 3 years ago, and to construct to this index, okay? So first, in this paper, we first construct this energy governance index for 32 OECD countries that is going to be representative for this period, 2000-2015. And second, we use this instrument to elaborate all this instrumental variable approach, okay? So I'm going to go very quick for the first part of the paper, okay, this governance index, and I'm going to focus on the second one, that is the new one, the previous one, the energy governance index we presented 2 years ago, in fact. So, but just only several slides about that, okay? So if we go to this report by the International Energy Agency, we get that energy efficiency governance is the combination of institutional coordination arrangements, also legislative frameworks and funding mechanisms in order to improve the energy efficiency of the economies, okay, of the countries. This is let's say the theoretical framework in the construction of this index, okay? We have these three pillars that they're the enabling frameworks, the institutional arrangement, the coordination mechanism. We have these categories that are included in these pillars that are related with law and decrees, strategies and action plan, funding mechanisms, implementation agencies, resources requirement, okay, targets, evaluation targets, no, this definition. So basically what we do is that we collect information. I will tell in 1 second, the source, and we collect the information, quality information on all these all these aspects, okay? Then we aggregate to the pillars, okay? And then we aggregate to energy efficiency governance, okay? This is the detail of all that is included in the paper. I don't have too much time to say more about that, okay? If I want to move to the second part. But just only to emphasize how do we collect all this information, okay? This is a really tough, having a really tough research project. We have analyzed more than 1,800 entries of energy efficiency measures for all these 32 countries. Okay, and we have collected this for the International Energy Agency energy efficiency database. Okay, and all these measures, okay, we have followed. No, we have basically for each energy efficiency aspect, and according with the policy measure implemented, we generate a rank of countries and provide numbers from 0. That means that 0 implementation of this particular category to 4. That is that this category has been fully implemented in the country. And after that, we repeat this of all of these categories. Okay. Then we aggregate to the pillars, and then we aggregate to the index. Okay. So sorry to explain this too fast because there are a lot of work and a lot of details behind, but I have to say that we have made a lot of robustness checks and analysis in order to make this index. This is broadly speaking the result of this index. Okay, this is the level. So the index goes from 0 to 4. Okay, 0 is the worst situation, the worst governance index. 4 is the highest score. This is the scale that is commonly used in this index, composite index literature. Okay. Oh, sorry. So we have here like Germany and Denmark are the countries with the highest governance. Spain is here in the middle. Here we have Norway. Here we have Greece. Okay, the average ranking is about 2.42. We have not sufficiently enough heterogeneity between countries, okay, for this index. But okay, and what I say, I mean, all the details of this is in the paper. So let me move to the second part. That is the new one. That is the one that I want to focus more on in the presentation. So the empirical approach is basically this is the starting equation, okay? This is the GDP growth. This is the endogenous variable. These are fixed effects, country fixed effects, and yearly year temporal fixed effects, okay? And what we have basically, and this is the explanatory variable, that is the energy. So this is to analyze the causality from energy growth to GDP growth, right? So we need to find this instrument. Okay, and the first step of this approach, basically we use this instrument that is this version of the energy efficiency in governance indicator and other variation. Okay, we try also to combine, to cross this energy efficiency governance index with, for example, oil price shocks, with trade shocks. Okay, so we construct several versions of this instrument, but let's focus on the primitive one, that is this index, the energy governance index, okay, that we construct. So the first step, this is the instrument, okay, and the second step is to estimate the first equation by 2 state least squares, right? What about the other side of the causality? So now from GDP, no, from GDP growth to energy growth, okay? So here we follow Bruckner results and Ciccone. There are many papers in well-reputed journals, okay, from the Journal of Economic Growth, American Economic Review also did. And here, what it focuses that if you are able to find a nice instrument here, you can construct another instrument for the other side of the causality. That is basically the adjusted per capita GDP series to change in energy consumption. So, broadly speaking, is the residual of the previous equation. But the previous equation needs to be estimated by the instrumental variable. Okay? So basically what they show is that if you use this variable, this adjusted per capita GDP growth series as an instrument for this side of the causality, you can obtain also consistent and unbiased results. Okay, and then you estimate also by two-state least square, right? So we test, we go through many tests. Okay, the over-identifying test, under-identifying, weak instrument test. I'm not going to mention all these tests. Okay, so let's move to the first stage result. This is the estimation result of the first stage equation. Okay, the first stage equation, remember, is this one. Is the instrument, so our energy efficiency governance index, over the growth rate of per capita energy consumption. Okay, this is the first stage of this instrumental variable approach. And basically what we find, I'm going to just focus on several results, okay, several parts of the table, is that the coefficient is negative. So the higher is the energy efficiency governance, the lower is the per capita energy consumption growth. Okay, controlling by fixed effects, by temporal fixed effects, and so on and so forth. Okay, and to quantify the impact, okay, we find that increasing this energy efficient governance in one standard deviation, that is about 0.78. Okay, it is more or less 1/3 of the average score. That remember was 2.42. Would lead to a reduction in energy consumption annual growth close to 0.5 percentile points. In other specification, we obtain that this reduction can also be about 0.65 percentile point, which is a significant magnitude. Okay. Notice, okay, that because we have, this is just only a point, we have made many exercises related with this, but just only to give you a flavor of that, is that notice, of course, that because we have this heterogeneity between countries, okay, how can we improve one standard deviation? That depends on the country, okay? And for example, if we look at the data of the governance index of each country, we have that, for example, in a country with a low development enabling framework like Netherlands or Turkey, energy government can be easily improved by drafting additional laws and decrees that cover new sectors like buildings, industry, and appliance, or extending existing regulations. Also, in countries like Austria, they show a low coordination mechanism area. No, we can improve easily this by this one standard deviation. Okay, this the evaluation mechanisms of the energy efficiency policies, right? So let's move to the result for the first side of the causality. So from energy to per capita GDP. Okay. So these are the result when we do not use instrumental variable. This is for pool OLS. Okay. So what we obtain for pool OLS, so without doing this instrumental variable approach, we have that the coefficient is positive, but very small. They are more or less.
Or is Gustavo also frozen for the others?
Sorry? Sorry? Sorry, I have to be finishing.
I think it might be a case that Joachim has some kind of technical issue with can't see you.
I think he said something that it froze, so maybe we can keep on and see if he comes back. I think, yeah, it's been around 20 minutes, so yes, in order to have some discussion, maybe a good time like to maybe start closing in a couple of minutes.
Okay, but are you listening to me now?
Yes, we can hear you. I think it's problems with his
okay,
internet.
so,
Actually, he's out. So yeah, let's keep on.
okay, okay. So here, okay, so here are the results for the pool OLS. Okay, so they are like a small elasticity. Okay, like 0.2. But when we control when we use instrumental variable, we have that this elasticities is also positive, but even close to 1. Okay, so they are very high. And our interpretation here is that what we find is that the energy consumption growth driven by energy efficiency governance shows a much stronger effect on economic growth. Okay, recall that when we use instrumental variable, basically what we are doing is that our energy consumption is not overall energy consumption. It is the energy consumption driven by energy efficiency governance. So what we're finding here is that if energy consumption is driven by improvement in energy efficiency governance, the impact on per capita GDP, so in income growth, is much higher than if we consider any increase of energy. Okay, and we believe that this is a relevant result. What about the other side of the causality? Okay, from GDP to energy. Here, we have that if we look at the pool OLS results, we have the typical positive result and with an elasticity of about 0.5. Okay, and here is probably the most surprising result. If we estimate this by instrumental variable, what we obtain is that the sign change. So we obtain a negative coefficient, but the negative coefficient, a very high negative coefficient. So about -2, -3. Okay, and this is a lot. So our interpretation here is that controlling by the double causality in this side of the causality. Okay, so isolating the increase of GDP from energy, which is the other side of the causality, development implies more efficiency, and that implies more energy efficiency and then less energy consumption. Okay, remember that our sample of countries, set of countries, are OECD countries, so they are very rich countries, right? So, however, when you do not control by this double causality, what we use to obtain is this positive relationship between development and energy consumption. Okay, but you control by the other side of the causality, the sign is the opposite. Okay, so I have finished. These are like the conclusion, but the conclusion is basically the summary of this. Just only to emphasize this last part. Okay, so that energy efficiency governance is the main driver for this existence of these two positive effects acting simultaneously. Is that on one hand it favors energy efficiency and economic growth, but also the energy governance is what is generating this improvement that income growth generates also a reduction in energy consumption. Okay, so therefore, since economic growth and energy consumption are essential aspects of the abatement of environmental damage, our results also indicate that energy governance can play a remarkable role for this decoupling, okay, carbon emission from GDP growth. Okay, because this improvement in energy governance makes that we can reduce energy without affecting GDP growth. Thank you very much. Any question? Any?
Okay, thank you very much, Gustavo, also for this very clear presentation and particular for staying in time. If you have questions, we now open the floor for questions. Please raise your hand, turn on your mic, and turn on your video so we can see you. Are there any questions from the audience? Don't see any hands raised. Then maybe I can ask a question in particular to which I think is the most innovative part, which is this governance index that you developed. Okay, maybe one is more of a comment since you're trying to interpret it. You could, if you z-scored the variable before, then it would be easier to interpret because then one would just correspond to a change in the standard deviation. So that would make life a bit easier, in particular since it's an ordinal scale. So that's just technicality. What kind of robustness checks did you conduct? Because it's from what I understood, you're basically adding up and allocating equal weights to the individual elements within the 3 subsections, and so maybe you can inform us a bit on how this was constructed and how was it rated? Was it consistently rated? Did you have several people rating this, and then what was the the overlap of the rating scores? Or the third question may pertain to, from what I understood, there were 3 elements. Yes, the green, the blue, and the red. Did you play around a bit and see which one of those, how sensitive your results are if you look at just 2 of them or 1 of them, and which one is the one that seems to be driving the results? You mentioned that you had conducted a couple of sensitivity analysis, so it would be nice to enlighten us on this.
Yeah. I mean, we have done a lot of things, and most of them are in the appendix, in the online appendix, and now they are too famous. So yes, regarding the first point, yes, I mean, the easy way to aggregate this, of course, is our starting point. It's like the raw index is we aggregate using sample average. So basically, to each of these elements here, we provide a number that goes from 0 to 4, okay, according to all this revision of this of all these decrees, okay, this 1,800 entries, and then we sample average, okay, all of them. Then what we do is that we have also conduct, like, for example, principal components. So we go to the other side of the, just forgot of sample average. Let's use a non-parametric statistics method, like the principal component analysis, and repeat everything. And also we try to do something, thinking a little bit. You say, okay, according to what we have read and what we have learned, let's try to weight more some part that we believe, or that the International Energy Agency say that they are more important, more relevant. And at the end of the day, the rankings of the countries are very similar, quantitative results are very similar, and almost everything is very similar. Okay, so this is our main conclusion for that. In fact, our results are based on the sample average result, because they are the easy to interpret. And if the ranking is not changing by using another more sophisticated, that they are very difficult to interpret, because I mean, how can you interpret the principal components, weight and so on? So at the end, our results are with sample average, but it's because the rankings using a more sophisticated method of aggregation, they didn't change. And regarding your second question, is probably the most important one, and I think that is the most important issue. I mean, it's the most relevant policy issue, right? I mean, okay, now let me know which is behind this black box that is our energy efficiency governance. Okay, so we have conducted several analyses trying to basically repeat all this regression using individual categories and pillars. And at the end, the enable framework, so this first pillar, is the most relevant one. So, but it is true that we need to do a little bit more effort. I mean, we need to understand a little bit. We are thinking right now on performing some kind of decomposition of the index, and then I don't know, using some decomposition approach, and maybe right now what we're doing is that, okay, let's take the score for these pillars and run the same regression. Instead of using the energy efficiency governance index, just only use the enable framework index or the institutional arrangement index, okay, or even each category. Okay, this is a good thing for not using the same rank for all the steps of the index. And at least in these preliminary regressions, okay, without thinking too much, we have that these pillars are the more important one. But we need to do more about that. But this is the most important part. You're right.
Yeah, thanks. I think that's a very, very important insight. Thank you. I think I've already asked 3 questions. There may be others. There may be others in the audience. Other questions pertaining to Gustavo's presentation? Maybe I will slightly abuse my role as moderator and ask another one. I was a bit surprised to see that that the Netherlands were on the same level as Turkey. Maybe this is reflecting my ignorance of this issue, but that's not something I would have expected. And I was thinking, well, maybe this is because the index is constructed in your analysis at a very aggregate level, at the aggregate level of a country, right? Have you considered, or does data allow this? I guess for energy efficiency or consumption, that's possible to look at sectoral level, so industry level, or even certain industries, or the household level, transportation. This all gets kind of lumped up in one index. Is that feasible, or is that something you're thinking of doing as a next step?
This is a request of a referee 1 year ago. And
it wasn't me. I was not refereeing.
Yeah, I guess because you don't want to discover it yourself. I mean, at least using this database. I mean, the database we're using. I have to recognize that that have. I mean, the tough work has been made by Josue Barrera. He's a PhD candidate. Hopefully, in several months, he's going to be a doctor. PhD, but so he, under the revision of all these entries in this database, okay, the database from the International Energy Agency efficiency database. This is a nice database because it is a homogeneous database, so this information is common to all countries, so we can compare. This is also another purpose and another weakness of many of the index, okay, that we can see in the literature is that, okay, how can we compare things across countries? No, this is a very difficult task. So for that reason, we focus on this index. I mean, on this database that is at least it is homogeneous. And also, what is true, and so there is some information. There is some information at the sectoral level, but it is true that it is like. I mean, I don't know. We need like 2 more years, or no, 3 or 4 PhD candidates to go through this. So it is like, because at the end, it's like all these 1,800 entries. They are not like no, with information is there. No. You have to read all the document. You have to extract the information from this document. So it's like, so there are some information. But I'm not sure that we have like a perfect homogeneous information, probably from the transport sector. No, I remember talking with Josue, and he told me that for some sectors we could find information. One of them is the transport sector. But I mean, they are not like the information is not specific. For the sector, so we can find some information. This is very relevant, very, very relevant issue. And I agree with you that this aggregation, to be this in aggregate level, yeah, there are some. For example, in the case of Netherlands, you can see the what is small is the enable framework. So probably no, Netherlands is not very well developed. This is information only until 2015, maybe. No, since 2015 to 2020, they have developed a lot of laws and decrees and strategies and action plans and funding mechanisms. But at least by the date we construct the index, relatively speaking, with other OECD countries, because this index is in relative terms. Okay, it is not absolute terms. So we compare with all the set of countries we have. They are. No, the lowest position is this one. Is the orange one.
Okay, great, Gustavo. Thank you very much for this presentation. Good luck for the health of your son and also with the reviewer.
Thank you
And
very much.
you may have to leave us a bit earlier to take care of your son.
Yeah.
So you
I'm gonna stay
apologize.
15
And-
minutes.
Okay, thanks again. And we'll
Thank
now
you.
move on to the next presentation, which will be on the long-term energy efficiency and decarbonization trajectories for the Swiss pulp and paper industry. And I think Michel will share his screen. Michel Obrist, he's I think a doctoral PhD student, engineering background at the renowned Paul Scherrer Institute in Switzerland. The floor is yours, Michel.
Yes, thank you. Can you see my screen and hear me?
Yes, perfectly.
Perfect. So as I already said, my presentation will be on long-term energy efficiency and decarbonization pathways for the Swiss pulp and paper industry. And also thanks to the introduction by Joachim Schleich, I don't need to introduce myself once again. So I'm a PhD student at Paul Scherrer Institute in the energy economics group. So today I will give you a quick introduction on the industry sector in general, on the pulp and paper industry, and on the energy and climate policy that we have in Switzerland, and then give you kind of a motivation for my work. Then followed by the methodological part, how I developed my energy system model, how I modeled the industry, and so on. And then I will present the results for the pulp and paper industry. And in the end, we will, of course, have time for questions and for a discussion. Well, let's start by looking at the final energy consumption and the CO2 emissions in the Swiss industry. What we can say is that in 2018, the industry contributed with 18% to the final energy consumption and with 19% to the CO2 emissions, which means that looking at the industry sector in energy efficiency pathways as well as in decarbonization trajectories is very important. What is special about the industry is that not all the CO2 emissions are related to burning fuels, so not all are energy related. Some are also process related from chemical conversion, for example. In today's presentation, I will mainly talk about the energy consumption in industry, but I would like to add here that there's of course also an economic component to the industry. So industry contributes in Switzerland with 25% to the GDP, and around 1 million people are employed in industry, which means there's also a social component to it. But let's focus on the energy and on the climate component now, and let's look at the Swiss energy and climate policy. So in Switzerland, we have what we call the Swiss Energy Strategy 2050, and there the government has defined some indicative targets. The energy reduction per capita should be at least 43% until 2035. There's also a target for the electricity reduction. If that's really realistic is another question, because often when you would like to improve the energy efficiency, it leads to electrification. Then Switzerland has also signed the Paris Agreement, and in this context also announced a net zero emissions target by 2050. And very soon, this Sunday, we're going to vote on the referendum on the revision of the CO2 law, and that's targeting a 50% reduction of the greenhouse gas emission until 2030. So this whole energy and climate policy brings us to my main research question. So how can the climate and energy policy goals be reached? And what are the implications then for the Swiss industry sector? Why is my work relevant? Well, previous studies, they often focus on potential of specific technologies or energy efficiency. improvements, but what they do not investigate often are transformation pathways. So in which trajectory can we reach energy efficiency goal as well as climate policy goals? And there's in that context no detailed long-term scenario analysis. And what is often neglected is the interaction with the rest of the energy sector. On the other hand, we have scenario analysis with energy system models, and they contribute to the energy technology development, and they identify policy strategy. However, often these energy system models, they have not really an investigation of the industry sector on a detailed production process level. And they have a very general view on technology development as well as process improvements. And to overcome this research gap, I started with the Swiss Times energy system model. That's a cost optimization model that we have developed here at PSI. And it's a partial equilibrium model, so it only considers the energy system and performs, as I said, a cost optimization, including investment costs, operation and maintenance costs, and taxes, and so on. And this model has different demand modules. Industry is one of them, and that's the demand module that I'm going to focus on. And what I did is I expanded the industry module with a very new modeling technique. And this modeling technique includes production processes as well as product and material flows. And that gives us then the possibility to include specific process improvement and also efficiency improvements of single process steps. And that also enables the options to really include process-related emissions at the process step where they occur. This is not that relevant for the presentation today, as the pulp and paper sector has no chemical conversion processes. All in all, we can say that this allows a more detailed and more accurate analysis. And then one minor point, but this is very important for the pulp and paper industry, is that I distinguish between different temperature levels of process heat. Previously, process heat was often treated as one demand commodity, and the different temperature levels were disregarded, which is very important if you analyze the technologies to supply process heat. So here's a more graphical overview how I tackled this problem in my PhD. So we have divided the industry sector into 4 main subsectors, and we're going to cover the rest as other industry. And then we have a one-way coupling to the Swiss Times energy system model. The goal is ultimately to fully integrate this industry sector model. What I can also say here is that with this modeling technology or with this model development, we have the opportunity to also analyze cross-cutting technologies. I gave some examples here, and we can see what role they play in the different industry sectors. Today, we're going to focus on the pulp and paper sector. So to start with, I just want to briefly introduce to you that what the pulp and paper industry even produces. So the main products here are newsprint and packaging paper, and but there are also other paper products like graphic paper, tissue paper, and so on. And you can also see that they vary with their specific energy consumption. In the past, the CO2 emissions as well as the energy consumption has decreased. This was not only due to energy efficiency improvement, but also to because due to the fact that production has decreased, especially in 2017 to 2018. one of the paper mills went out of service. So let's look at my model a bit in a structured way. So I modeled all the production processes and the material flows, as I said before, as well as the temperature levels. And I started with the pulping processes, as you can see on top, and then created a model for the paper mill itself and the production process of different paper products. What I can say here is that the production process is very similar for all the products. However, not all the processes are needed for all the products, and also the specific energy consumption is not the same for all the processes. Then what I would like to point out here as well is that in Switzerland we use mostly recovered fibers as a raw material. There is a mechanical pulp production, but most of the chemical pulp is imported from abroad. So there's not really a primary fiber production in Switzerland. So before we look at the results, I would like to give you some background on the scenarios that I have defined. We saw on the second slide of my presentation the energy and climate policy of Switzerland, and in line with that, we have created three scenarios. The first scenario, of course, was the business as usual scenario, where we assume an unchanged market environment, no further policy intervention to reach climate or energy targets, and we followed existing trends in fuel prices and technology development, as well as for demand. What I also need to say here for the energy sector, we assumed a nuclear phase out, which is actually planned by Switzerland. Then, in addition to the assumptions of the business as usual scenario, in the energy policy scenario, we target an energy reduction, and we would like to explore what is possible within the pulp and paper sector and how would this look like. And then we have defined a climate scenario with the ultimate goal to reach net zero in 2050. For all those three scenarios, they are in line with what we have analyzed with our Swiss Times energy system model, which means we took the fuel prices for all the scenarios from the Swiss energy system model. So let's look at the results. We can see that even in the business as usual scenario, we have a reduction in energy consumption by minus 23%, and a reduction of the CO2 emissions by almost 70%. This is mainly due to the phase out of natural gas, which is replaced by biomass. Yes, but a further reduction of the energy consumption is possible, as indicated in the energy policy scenario, and it is possible to reduce the energy consumption by 32%. I should note here that even a further energy efficiency improvement would be possible if the heat supply would be electrified with high temperature heat pumps. However, from a system perspective, it's not desirable to substitute the district heat as well as the waste consumption, which is used in combined heat and power plants. Then if we look at the climate scenario, we can see that in the short term, biomass plays a role here to decrease the emissions. However, the competition for biomass in 2050 is so high that there is a very high price on biomass in 2050, which means that ultimately the whole sector is, or the whole heat supply is electrified besides the district heat consumption. Yes, we're going to look at that a bit more in detail. So if we look at what is actually contributing to the energy efficiency improvement, and this now is only possible because of this new modeling technique, and we can see that in the process section, the drying section contributes the most, which is not a surprise because it also consumes the most energy. Then what you can see is that pinch analysis as well as motor efficiency improvements, they contribute as well. And then electrification of the heat supply, mainly with high temperature heat pump. That's where you can see the difference, for example, from the business as usual scenario to the energy policy scenario. There's a huge potential to improve the energy efficiency. Well, the most interesting thing is to compare the scenarios in terms of process heat supply. You can see that in the year 2020, the pulp and paper industry mostly relies on boiler technologies to supply the process heat. And those technologies, they phase out in all the scenarios and they get replaced by CHPs as well as high temperature heat pumps. In the business as usual scenario, it's mainly biomass and waste CHPs. In the energy efficiency scenarios or the energy policy scenarios, it's high temperature heat pumps because of their high efficiency. And in the climate scenario, as we have seen before, it's biomass in the short term and then electrification in the long term. If we look at this from the economic perspective, we can see that the energy related costs, they do not increase that much in the business as usual scenario. If we look at the EPOL scenario, we can see that there are higher investments in the short term to reach a better energy efficiency. But in the end, in 2050, the energy related costs end up almost at the same value as the business as usual scenario because of the energy efficiency improvements. And then you don't need that much fuel anymore. But if we look at the climate scenario, we can see especially towards 2050, the costs explode. And if we analyze the whole period from 2020 to 2050, the energy related costs in the climate scenario are almost 50% higher than in the business as usual scenario. As I said, I will take a closer look at the climate scenario and at the electrification. So what I said before is that we assumed due to the high competition of biomass, we have a very high biomass price in 2050, which is almost 140 euros per gigajoule in the climate scenario. So we also wanted to analyze what happens if we decrease this biomass price, and we chose a biomass price of 42 euros per gigajoule. That the basic assumption behind that is that we assume that biomass increases from 2040 to 2050 at the same rate as other fuels. That's how we defined this 42 euros. And what we can see then is that, of course, the sector does not get fully electrified anymore. Instead, biomass also plays a role then in 2015, becomes the major fuel. Then this is not a big surprise, but what we can see if we look at the economic component is that it does not even provide us such an advantage in terms of energy related costs, which means the energy related costs, they only decrease by 3% in this solution. So let's sum up. So I've shown you different energy and climate trajectories for the pulp and paper industry. And these trajectories were only possible with this new advanced techno-economic bottom-up cost optimization modeling technique. We've seen that even without major policy intervention, the pulp and paper industry will reduce their energy consumption and also reduce their CO2 emissions. Nevertheless, we can even reach a further reduction of the energy consumption, and this is possible through electrification of the process heat with high temperature heat pumps and also with process improvements. I've also shown a cost-efficient way to decarbonize the pulp and paper industry, but this relies heavily on biomass in the short term, and additionally on high temperature heat pumps in the long term in case of biomass scarcity. So let's also look at the end a bit on the limitations of this work. Well, we have assumed perfect foresight for the whole period until 2050. This means we end up with the optimal solution here, but this might not be the real case. Also because the optimization includes, of course, the full time horizon, but the investment decisions are often made based on short-term projections. So a myopic view would be also a variant here to analyze it. And then in the end, I would say to analyze the full implication on the energy system, that needs an integrated model, which is also planned in the future work. That's mainly because then we can allocate district heat, we can allocate the waste to the different sectors, as well as the emissions to reach net zero in the whole energy system. So that was it. Thank you for joining my presentation, and now I would be open for questions.
Thank you. Thank you, Michel, for again a very clear presentation. I open the floor now to questions. Remember, raise your hand, turn on your microphone, and turn on your video so we can see you. Are there any questions? Maybe I'll be the icebreaker. According to your results, the climate policy scenario is the one where the costs are highest, and they're distinctively higher than in your energy policy scenario. Yet when we look at total demand, it seems to me that the demand is even slightly higher in your climate policy scenario than at least in the energy policy scenario. So I find this a bit odd, or maybe you can explain us a bit more about your model price elasticity of demand, or how that is integrated in the model. Yeah, exactly. That's the slide. Yeah, if you go to 2050, and if you look at final energy consumption, the last bar is higher in the climate policy scenario than the energy policy scenario, even though costs are significantly higher.
Yes, but so on one hand, we do have also an increased consumption of district heat that maybe explains the higher final energy consumption. I can assure that the demand for paper is the same in both scenarios. So there's only the difference in final energy consumption, and probably it's because of the increased district heat consumption, because with high temperature heat pumps, you can reach approximately a coefficient of performance of 2, which makes it much more efficient to supply process heat with high temperature heat pumps. If you consume then district heat, this means in the end that compromises your energy efficiency when you just look at your sector without considering where the district heat is coming from. If you look, of course, at the system perspective, then the energy efficiency might be even better in the climate scenario here. But if you just look at the sector itself, then we can see this difference in final energy consumption.
So the higher energy costs, it's not translate into higher costs for paper, for the final paper products, which may have an effect on demand. That's not something that's included in your, you mentioned no. It's a partial equilibrium model. Okay, so you basically assume demand is constant.
Exactly.
Okay.
So
okay, I got
so
it. Okay.
The demand is actually exogenously defined. Yeah. So there's no demand flexibility here. So this is also in a partial equilibrium model. It's also difficult to include that because the energy related costs, we just model the energy related costs here, and that might take up 15% of the total costs to produce paper, and that's not, of course, not everything that defines then the price for paper, which means the influence on in the end is not only driven by the energy costs.
Yeah. Okay, thanks. Very clear. Other questions? Questions to Michel's presentation? I'm not very familiar with the technologies there, so especially the heat pumps for high temperatures more than 200 degrees. Is this technology already developed, or is it at a rather early stage? I mean, lower temperature heat pumps there. That's quite a mature technology, but what about these high temperature heat pumps?
So current state of the art of high temperature heat pumps, they go up to 150 degrees Celsius, and temperature lifts of around 90, maybe 100 degrees Celsius are possible. That means you always need a waste heat source to operate a high temperature heat pump, which means in the process you also need the opportunity to recover waste heat from your process and then upgrade it with a high temperature heat pump to a higher level. In this case, we do have the opportunity to recover waste heat from the process. We assumed that further development reached to an expansion of the application range up to 200 degrees Celsius. That's what we assumed. And development is focused at the moment also on refrigerants to actually, and on components to actually achieve this high temperature. So we're optimistic there, and that would perfectly fit to the heat demand of the pulp and paper industry, because the highest demand is for drying processes, which is exactly in this temperature range. So we don't have any very high temperature heat demand, so 200 degrees is actually sufficient here. This is of course not true for the whole industry, but in this case there's a huge application potential for high temperature heat pumps.
Okay, thank you. There's a question by the next speaker. Yes, Antonios?
Yeah, I just wanted to check, and apologies if it's been mentioned, I somehow missed it. Do you have any idea what is the driver, essentially, which kind of fuel is driving this kind of significant difference between the climate scenario and the energy policy scenario?
I didn't understand the question. So the driver towards what?
We see that there is a significant difference in the cost of energy between the energy policy scenario and the climate. Yeah. So yes. Do you have any idea? Have you explored what is the driver behind this result? Why we have this kind of significant difference? Because the differences in energy consumption, it doesn't seem to be as big between the two scenarios.
Yes, well, in the energy policy scenario, compared to the CLE scenario, we have assumed completely different fuel prices because we get the fuel prices from the energy system model that considers the whole energy system. And what I can say is that, for example, electricity in the climate scenario, the electricity price is much higher than in the energy policy scenario because in the climate scenario, also the other sectors have to decarbonize, which leads to a high competition on the electricity as well as on the renewable potential that we have. And if we compare that to the energy policy scenario, where the other sectors, they only need to focus on energy efficiency. That means we have even a decrease in energy consumption, which means that the competition is much lower. And in addition to this, in the climate scenario, we see very high price differences between the different hours as well as between the seasons. So we see very low electricity prices in summer and very high electricity prices in winter. And this is not the case for the energy policy scenario, or not as strongly as in the climate scenario. And I think this explains the difference that we have in the results.
Okay, thank you. Thank you again, Michel, for your presentation and the audience for the questions. Good luck for the plebiscite this weekend in Switzerland. And we'll move on to our third speaker in this session on energy efficiency. The presentation will be on given by Antonios Katris, who is a PhD economist and research associate at the Center for Energy Policy at the University of Strathclyde in Scotland. And he'll be talking about the funding of UK residential energy efficiency, the economy-wide impact of Ecole and its alternatives. So Ecole is the energy company obligations. So we'll learn more about this in the next 20 to 25 minutes. The floor is yours, Antonios.
Thanks, Joachim. Although I have to say that much like Gustavo said earlier on, this was initially submitted for the previous year's conference. And since then, we have moved beyond this kind of point. So we have published about Ecole and we're looking more into the alternatives of it. But thank you very much for introducing me. And I guess I'll just start the slides and get right to it. So yeah, as Joachim said, I am from the Center for Energy Policy at the University of Strathclyde. And I think a fitting starting point is to have a very quick look at what is happening in the UK policy landscape in relation to energy efficiency. And what we see is that it is one of the key components of the UK's effort to achieve net zero greenhouse gases by 2050. Actually, there is legislation in the UK specifying this kind of target. And between 2019 and 2020, we saw a number of important policy documents that actually included considerations of residential energy efficiency as being part of the approach that they used. Sorry. One of the important things in relation to energy efficiency is the fact that the clean growth strategy, the UK clean growth strategy, states that there is an aim to bring as many UK homes as possible to an EPC, Energy Performance Certificate, Band C by 2035, and having a main focus about this target on the able to pay households and also the private rental sector. So up until now, the main funding mechanism, the main approach used to support energy efficiency improvement projects was the energy company obligation, Ecole, in which case the major energy suppliers, they have to meet specific targets that the energy regulator is setting. And to do that, they have to find appropriate projects to support. essentially it makes them act as centralized providers of energy efficiency improvements. The problem is that this whole approach introduces substantial costs in terms of finding the projects, administrative costs, and also the main idea behind it is that you pass the cost to your consumer base through their energy bills. And yes, we have found that it can enable substantial economy-wide benefits because of the efficiency gains that it enables. And also it could help avoid any negative impact to the low income households if you don't manage to achieve the energy efficiency gains that you were hoping to achieve. Actually, you can read that in the paper that I have included here. But the fact that you're passing the cost to the consumer base is something that is being considered as an issue, essentially. And that's why we're seeing that there are some early indications that there is a shift in the energy efficiency policy. We saw in July 2020 that the Green Homes Grant was announced as part of the post-COVID-19 recovery package. And also there was some interest to try and expand it beyond the initial timeframe, although this did not actually materialize. And as I said, there is this general view that within the policy community that there are limits to what you can actually pass to the consumer's energy bills, especially considering that as you electrify more services like transportation and heating, for example, this will inevitably bring additional costs to the households, to their energy bills. And the problem here is that if you try to socialize the cost through the energy bills, then you have the potential to disproportionately affect the lower income households. There is actually a UKERC report detailing exactly this challenge. So there is a consideration here of what kind of alternatives you could look to use in order to promote residential energy efficiency improvement. So this is exactly what we are looking at in this work. So we explore 4 alternative ways that you can use in order to promote and fund residential energy efficiency improvements. The simplest one is a regulation, introduction of a regulation that basically requires household property owners to bring their properties to EPCC as per the target in the Clean Growth Strategy. We then have the government issued grants as another approach. And then we have 2 different interest-free loan approaches. So one with a short 5-year repayment period and another one with a longer 25-year repayment period. And as you can understand, regulation and loans, essentially they pass the cost to the beneficiary households. Under the regulation approach, you have to cover the entire cost within the enabling stage of the program. This is the period when the retrofitting takes place. On the other hand, when you use loans, you can break the cost into smaller bits and spread it over multiple years. But of course, the repayment will have to start when the retrofitting takes place, which means that in many cases, the repayment will exceed the duration of the retrofitting program. And the key thing here is that because we assume that repayments of the cost take precedence over anything else, any other need of the households, essentially what the regulations and loans do is they reduce the disposable income of the beneficiary households until the cost is covered, and therefore they affect the household consumption. On the other hand, if you use grants, obviously you don't put any pressure on the income of the households receiving the grants, but there is the challenge here that you could have, and most certainly have, government budget deficits. So you need to find ways in order to raise the necessary funds for the grants. One way is to use some kind of progressive taxation. So for example, the income tax, although in this piece of work, we have not explored how this is done. So for our work, what we use is the UK Envy CGE model for the UK. It includes all the sectors in the UK economy, and we have aggregated them into 34 of them, including 5 energy sectors, which include coal extraction, crude oil extraction. We have refined petroleum, electricity, and gas distribution. And it has a CLEM production function, so labor, capital, energy, and non-energy intermediates. You have the consumption of energy. Sorry, for some reason it keeps going on the next slide. So yeah, you have the consumption of energy and non-energy goods, for example, by the households, but not exclusively. You have competitive good markets, and you also have 2 external regions with which the UK is trading, but the goods, the domestically produced goods, are imperfect substitutes to the externally produced goods. So the imports and exports, basically, they respond to changes in relative prices. We have 5 household quintiles in the model. So the households are broken down in 5 groups based on their gross income, with HG1 being the lowest income quintile and HG5 being the highest income quintile. And we use a 2016 social accounting matrix for the UK. I know this might sound a bit out of date, but unfortunately, this is the latest data available to us in the appropriate format. They were actually published last year in 2020. In terms of how we model the delivery of the energy efficiency, we assume that 2 sectors are being involved. The major share is going to the construction sector, which is doing all the retrofitting, insulations, windows replacement, and things like that. And then we use the manufacture of fabricated metal product sector as a proxy for different heating system installations, and that's a small part of the total activity. I would like to point out here that we don't model the use of any specific heating technology or heating system technology. This is something that will need additional research. And I'll come back to the thing that I mentioned here about the 15-year programs, because we look at short and longer term ones. But the cost and distribution among households of the total funding for the 15-year program, as we look at, it comes from internal analysis at the Department for Business, Energy and Industrial Strategy, BASE, but collaborate, some employees there, civil servants, they collaborated with us in this project. And in terms of the efficiency gains data, they come from the National Energy Efficiency Database. So in order to look at some results here, first of all, we explore an approach that is quite similar to how Ecole is being implemented so far. So short year, relatively small scale programs. So we have a 4-year program, £4 billion, which are spread equally among the whole duration of the program. And because the producers assume that, much like Ecole, there will be a new iteration after the end of the current program, they essentially expect that these 4-year programs will continue, although we don't model more than one in this case, and therefore they exhibit a myopic behavior. I would like to point out here that in our central case, we assume that there is a fixed labor supply, which is quite common for national models. And also we assume that there is a wage bargaining, the nominal wages are defined through a wage bargaining function, basically meaning that they are inversely related to the unemployment rate. What we find then is that a 4-year program, a 4-year energy efficiency program, if the efficiency gains materialize, they give you long-run economy-wide gains in a number of important variables. Here I focus on GDP, but you also have gains in household incomes, you have gains in employment and so on. The funding mechanism itself, it doesn't influence the long run results. Those results are only affected by the efficiency gains, and also which households are getting this efficiency gains, which households are being retrofitted. But they do have a transitory impact. They affect the time frames until you reach the long run. And we find that in our central case, with wage bargaining and fixed labor supply, and also with myopic producers, that the regulation has the potential to give you the greater temporary negative GDP impacts. That's because you have very large prepayment requirements early on, which restrict the household income and consumptions, and essentially lead you to up to 151 million pounds GDP losses by the third year, the year before the end of the program. If you use loans like short-term loans, 5-year loans, the repayment requirements per year are reduced, which means that you still have some GDP losses in some timeframes, but they are smaller compared to the regulation approach. And then if you use grants, obviously you avoid losses at all, but also a substantially large large repayment loan can help you avoid this kind of GDP losses as well. The interesting thing here is that the GDP losses are not necessarily linked to net employment losses. So we see that at least during the enabling stage, when the retrofitting takes place, there could be a temporary fall in the labor productivity. Now, the previous results were in relation to producers expecting further activity. But if they don't have this kind of expectation, then we assume that they exhibit some kind of forward-looking behavior, and the results look quite different. Essentially, any negative impacts that you observe in the previous case, they can be exacerbated, and also funding mechanisms that they weren't giving you negative impacts beforehand, they now do. The greater losses that you're getting are basically in the 25-year loan case, and this is linked both to the fact that it is linked to the fact that you have household income restrictions for a number of years, but the fact that you have forward-looking producers, they expect that this period is going to be much longer than the retrofitting activity, than the enabling stage. So adjusting their behavior accordingly, you can see that this extends the time in which you observe the negative GDP impacts. And similarly, when you have grants in place, you do observe again some temporary GDP losses, although the economy recovers a bit faster compared to the loans. One of the reasons explaining why you have this kind of negative impacts is that the producers are aware of the rising labor costs that you're getting, and labor and prices associated with the labor costs that they're coming as a result of the retrofitting activity. So you have competitiveness losses which affect exports, for instance, and as a result, they adjust the allocation of the resources accordingly and their production accordingly, hence the negative impacts that we observe. The comparison of the two essentially highlights how important it is, if you're going down the route of small-scale programs, it shows you how important it is to properly manage the expectations of the producers, so that there is confidence that the activity will continue rather than it will be a one-off thing. One thing that you can do is to remove some of the uncertainties is to go for longer term programs. In this case, we look at a 15-year program to achieve EPCC by 2035, and because it's that big and it achieves the targets that that has been set, we assume that this will be viewed as a one-off program and the producers will be exhibiting forward-looking behavior. The important thing here is that with a sufficiently long-term program, you can restrict the duration of any negative impacts, although because the volume of the activity is quite substantial, quite bigger than the shorter term program, there is the potential for greater GDP losses, although, as I said, for a shorter period of time. Similarly to the shorter term programs, the funding mechanism do affect the magnitude and duration of the potential negative impacts, but they don't have any effect on the long run results. And as you would anticipate, the smaller and shorter losses we observe are in the case of the grants, albeit with substantial potential for potential for substantial government budget deficit up to £5 billion. So essentially, this highlights that the choice of funding mechanism is important in like a wider net zero context. We can see that choosing the appropriate mechanism, it can help you move any negative impacts at times that those can be compensated by gains from other actions, because it's not just energy efficiency alone. And also, if this cannot be the case, at least you can avoid compounding the negative impacts from different actions. But then this brings an important question, an important issue that needs to be considered, and it's in relation to how do you time the activity? How do you distribute the activity across the different years? If you opt to go with early action, which means that most of the activity is happening in the first few years, the first 3 years of the retrofitting program, then you might find yourself needing up to 135,000 full-time skilled workers, which may not be available at this time. And also because you don't have the efficiency gains to counter the negative the negative pressures to the economy due to rising labor costs, you do get, for a period of time, you do get substantial negative GDP impacts. But the important thing here is that if you have support for a single parliamentary term, which is 5 years, you can enable up to 64% of the total potential efficiency gains. On the other hand, if you get your activity at the later stages, yes, you have small early costs, and you start adding some efficiency gains, which help you mitigate economic pressures at the later stages of the program. But the problem here is that if you don't get any support in the last parliamentary term, in the last 5 years, then you only achieve 35% of the efficiency gains. And then you have the steady action approach, which essentially spreads the entire activity over the entire duration of the program, which smooths out the labor requirements, any negative GDP impacts and so on. But the challenge here is that basically you have to ensure that there is ongoing support for at least 3 parliamentary terms, and this is a challenge in its own right. So just to sum up here, the first thing is that we can see that all implementation approaches and all the funding mechanisms, they can deliver long-term economy-wide gains if you achieve the expected gains. The funding mechanism, it only affects the transition until you get to the long run. And the role of the funding mechanism is essentially to help you time any potential negative impacts in periods that they are more suitable in a wider net zero context. The short-term programs, they can deliver positive economy-wide outcomes in many timeframes, but this is assuming that there is the expectation that the activity will continue. And this is a really important thing to do. You have to manage the expectations appropriately. because otherwise significant and longer term negative impacts could be, they are possible. What you can do to avoid the long-term impacts, to avoid any uncertainties, is to essentially announce long-term programs, long-term activity, which reduces the time of the negative impacts, but could lead to greater losses because of the higher volume of activity. And also, last thing, in the long-term programs, it's really important to time the activity within the duration of the program appropriately, because you need to make sure that you can meet the labor requirements to deliver on the retrofitting program, but also you need to make sure that essentially there is ongoing support and funding for the program. Otherwise, you won't be able to achieve what is the goal of the program. So, although being a bit late, that's me. Thank you.
Thank you, Antonius. Thank you. Very clear take-home messages and on the multiple facets of different funding mechanisms to improve retrofit in the UK household sector. Any questions from the audience? Antonius' presentation. No, I see you. Junko, are you trying to ask a question? Yes.
I'm trying to use my camera, but it doesn't work. Can you see my?
It works perfectly. We can see you and hear you.
Oh, really? Good. Oh, thank you very much. Yes, and now I can see my face as well. And thank you very much for the three speakers for very fascinating presentation today. And also, I would like to thank Professor Schleich to organize this session. Thank you very much. And my question goes to Antonio's presentation. In Japan, the household sector is a very crucial sector that we don't have any actions for climate change so far. While at the same time, we have lots of policy and measures in industry and power sector that we already introduced. Non-fossil fuel value trading scheme in power sector. Also, we have a voluntary action plan in industrial sector. Also, we have energy efficiency target. We try to set up the energy efficiency benchmark. Actually, I was involved to set up the benchmark for different kind of industry, like the pulp and paper. I was involved to the discussion how to set up the benchmark of pulp and paper, and that industry and power sector we have a lot of measures, but yes, as I said, household is our main issue, one of main issues for achieving our climate target. And UK is how should I say? UK is our reference country that you introduce lots of different kind of measures in household, and you try to introduce Green Deal, the previous administration, and now your country is carrying out Ecole for energy supplier. And I would like, my question is very general, that what is the tips for success to introduce policy and measures for household sector?
Thank you very much. I mean, it's this is something quite challenging. I mean, in principle, let me go a step back. I mean, originally there was this kind of thinking that the gains that you get from energy efficiency improvements, the benefits that you will eventually observe in your energy bills, it should have been enough to incentivize people to actually go on, find the appropriate funding mechanism, find whatever approach would help them to kind of retrofit their property. Unfortunately, we've seen that this is not the case. This is not something we explore in this piece of work. We assume that the money that they are there are actually being used. But this is a policy challenge in terms of how do you make a funding mechanism? How do you make some kind of support mechanism easy enough and like accessible by as many people as possible in order to actually achieve the kind of gains that you're hoping to achieve? And to be honest, I'm not sure that this has been that the governments, at least in the UK, they have found the perfect solution to that. They're trying different approaches, and devolved governments like Scotland is using a mixture of different kind of support mechanisms. The issue here is that there are perceived costs, there are like hidden costs in the whole process that we are not, at least personally, and that's not reflecting the view of my colleagues, it's just a personal view. I'm not sure to what extent the UK government has actually identified those costs and taken them into account when designing the policies. And this is the kind of analytical work that I think will be useful in the future, like incorporating social aspects, social research aspects into the studying of energy efficiency improvements.
Okay, thanks. And yeah, maybe Junko, you can look at the first speaker's scoring of energy efficiency policies in the various countries and see where they did well. Yeah, Gustavo's work may provide some guidance. Further questions?
Thank you very much.
Maybe I have one final very quick question. I mean, you were looking at different funding schemes, loans for households, different times of durations of the loans. I may have missed it, but is it correct that your assumption was that the government budget has to be balanced, so they cannot go into debt? So my question would be, if you relieve that restriction, your results, that may have an effect on your results, right?
Right. So you're correct in saying that, because initially that's exactly what we were doing. We were asking for a balanced budget, and in the paper we published, we are asking for a balanced budget. In this piece of work that I presented, we do not ask for a balanced budget. So the results, they are comparable. You don't see the difference between grants and all the other approaches. And yes, if you ask for a balanced budget through the income tax, for example, this means that you recycle any savings that they are they're manifesting after the the repayment, and after you get you start getting benefits from the inefficiency gains. So essentially you're introducing an additional source of gains for the households, which we don't have here. Although there are alternative ways that we could use to explore, for example, how the funds for the grants, for instance, could be raised. So one way that we explore in other kinds of work is that you can use some kind of lump sum payment to get the household to basically pay some kind of lump sum payment, which doesn't require that you have a balanced budget. So you can just limit the payments to to cover the amount of the grants, really.
Okay. I mean, that has implications on green growth strategies and discussions in countries about balancing the budget and going into debts and so on. Thank you. Thanks to all three speakers for the great and very clear presentations with interesting policy insights. This is the end of the session. The moderator has done a poor job because we run 10 minutes late. I hope you'll make it in time to the next presentation. Enjoy the remaining hours, I guess, of this year's conference, and enjoy the rest of the day. Goodbye and thanks again.
Thank you very much.
Thank you, everybody. Just a quick reminder, just to upload your slides. Have a good rest of the day.
Thank you.
Bye.
Thank you very much. Bye-bye.